Hey guys, welcome to the next video part of my gas laws video, and I'll be doing combined gas law in today's video. And in the last video, I think we did Gay-Lussac law. So now we're moving on, and this is the main formula. So let's just go to that slide. So here we have the formula for combined gas law. It's P1 times V1 over T1 equals P2 times V2 over T2. That is the main formula that uses all of the other formulas in it, and it can be manipulated in a way that each one can be used. So like we have our Boyle's law on the top, P1 times V1 equals P2 times V2. We have our Charles's law, which is V1 over T1 equals V2 over T2. We have our Gay-Lussac's law, which is P1 over T1 equals P2 over T2. And combined gas law, it's all of them combined. P1 times V1 over T1 equals P2 times V2 over T2. Also, something that we should note is standard temperature is 0 degrees Celsius or 270 degree Kelvin or 273 Kelvin. And standard pressure is 1 atmosphere or 101.3 kilopascals or 760 millimeters of mercury or 760 torr. You have to memorize all four of those, and over only two of them, only 1 atmosphere and 101.3 kilopascals are on your reference tables. Another thing to note is this equation, it's on your reference tables too. Do not be afraid to use your reference tables. So also temperature for any of these formulas that I've shown so far, temperature must be in Kelvin. I can't stress that enough. Kelvin, it's just Celsius temperature plus 270 degrees. Celsius temperature plus 273 equals Kelvin, or Kelvin minus 273 equals Celsius. That is also on your reference tables. So now that is it. I have no relationships for this one. So we're just gonna go to the sorry, I'm sick still. We're just gonna go to the practice questions. So the first question we have here is, if a gas occupies a volume at 100 milliliters at a pressure of 760 torr and 27 degrees Celsius, what volume will the gas occupy at 800 torr and 50 degrees Celsius? So we know that our formula is P1 times V1 over T1 equals P2 times V2 over T2. My handwriting on this gets progressively worse. Oh my god. Good enough. So here we have our first side is completely given out to us so far. So we have V1, P1, and T1. So you got 100 milliliters times 760 torr. Over 27 plus 273 is 300 Kelvin equals, so we're looking for V2. So we are given 800 torr, which is our pressure times V2 over 50 plus 273 323 Kelvin. So then again, we cross multiply like always. This entire side times this entire side. And when we multiply these on our scientific calculators, we want to multiply 100 by 760 first. So get 76,000 times 323, which gives us two. I'm just gonna write it down. That's an 8. Equals 300 times 800, 240,000 V2. Then you divide both sides by 240,000, and V2 should be 102 milliliters. Again, significant figures are important. So yeah, that is the first problem. It's not too bad. It's obviously a little more challenging. There's more multiplying to be done than in the other 3 formulas. But once you get this down, the other 3 are really easy. That is why my teacher taught us combined gas laws first. So we'll move on to the second problem here. I'll read it, then I'll set it up while you pause the video and try to solve it, and then you check with me. So at 100, a 1500 milliliter volume of a gas is collected at 849 torr and 10 degrees Celsius. What volume will the gas occupy at 283 torr and 30 degrees? So I'll set this up, you try to solve it, and then we'll see what the answer is. So this is the setup I got, and when I cross multiplied, I got 29,100 equals 284 V2. Then when we divide both sides by 284, we get no, wrong, sorry. Well, I was looking at a different problem. Sorry, we get, this is a big number, equals 80089 V2. And when we divide both sides by, so we get that number equals 80,089 V2. And we divide both sides by 80,089, we get 4,820 milliliters. Sorry for the mistake. I am really tired again. I hope this really helped you. I may do the rest of the gas laws unit next, or I might continue on the matter unit. I'm not quite sure. But I have this for now. Thank you for watching. I hope it helps, and I hope you enjoyed it.